Today's video is on integration using residues. In today's video, we are going to find the residue of z square by z power 4 plus 1 at those poles which lie inside the circle mod z is equal to 2. See here, we have to find the residue of this function at those poles which lie inside mod z is equal to 2. Clearly, from the question, f of z is equal to, this is z square by, this is z power 4 plus 1. And now in order to get the poles of this function, we have to equate the denominator to 0. So here the denominator value is z power 4 plus 1 is equal to 0. And here z power 4 is equal to minus 1. So our z value will be, this is minus 1 part, this is 1 by 4. So minus 1 can be written as, see here, minus 1 can be written as, this is cos pi plus I sin pi par, this is 1 by 4. See here, cos 180 degrees value is minus 1 and cos pi value is equal to 0. So in general, I am writing z is equal to cos, this is 2n pi plus pi by 4 plus I into sine, this is 2n pi plus pi divided by 4, where n value ranges from 0, 1, 2, 3. See here, these are the poles obtained when we equate the denominator of the function to 0. So if you put n is equal to 0, so what is our value here? So z value will be, if you keep n is equal to 0, this is cos pi by 4 plus I sin pi by 4. Clear? And next one, if you keep n is equal to 1 here, so this is 2 pi plus pi, 3 pi. So z value is equal to cos, this is 3 pi by 4 plus I sin, this is 3 pi by 4. Clear? And next, if you keep n is equal to 2 here, this is 4 plus 1, 5. So this will be, z value will be cos, this is 5 pi by 4 plus I sin, this is 5 pi by 4. And next, lastly, if you keep n is equal to 3 here, this will be 6 plus 1, 7. So z value will be cos 7 pi by 4 plus I sin times of 7 pi by 4. See here, if you keep n is equal to 1, 2, 3 and 4, so we got the values of the pole values of the function. So the four values of z are these. These are the four values of z. When we keep n is equal to 0, 1, 2 and 3. So we need all the values of these. As you know that cos pi value is equal to, see here, cos pi value is equal to 1 by root 2. So it is very clear. Please remember, cos pi by 4 means cos 45 value is nothing but 1 by root 2, and again sin pi by 4. So sin pi by 4 value is also sin 45, which is again 1 by root 2. Now I am going to substitute and calculate all these values. See, if I calculate each and every value here, the first one is cos pi by 4 plus I sin pi by 4. First one is, this is cos pi by 4 plus I sin pi by 4. As you know that cos pi by 4 is 1 by root 2. So z is equal to, this is 1 by root 2 plus I into 1 by root 2. So clearly our z value will be 1 plus I by root 2. So this is our first value. And the next one here is, the second value here is cos 3 pi by 4 plus I sin 3 by pi by 4. So we have to calculate this one. So in order to calculate this one, z is equal to cos 3 pi by 4 plus I sin, this is 3 pi by 4. In order to calculate this one, so we have to write this in the form of z is equal to, see here, this can be written as cos of, this is pi minus, this is pi by 4. So clearly if you take 4 as LCM, this will be 4 minus 1, 3 balanced. Next, sine of, this is pi minus, again this is pi by 4. So pi is nothing but, see, pi is nothing but 180 minus theta. See, I am drawing here this one. So if you start with 90 minus theta and end up with 90 plus theta. So again, this is 180 minus theta and this is 180 plus theta. And again start with 270 minus theta. This is 270 plus theta. And again this is 360 minus theta, 360 plus theta. So we have to start with minus and end up with plus. And again 180 minus 180 plus. 270 minus theta, 270 plus theta, 360 minus theta, and 360 plus theta. I have started from this. So this is the first quadrant. This is all silver tea cups. As you know that, so here everything is positive. So each and every term is positive. Here silver, sine and cosecant are positive. See here, sine and cosecant theta are positive. And next one here tan. So in tan, so tan and cot, tan theta and cot theta are positive. And next here cup, cos and secant, see cos theta and secant values are positive. See here, basing on this, cos 180 minus theta, so here is 180 minus theta, here only sin theta and cosecant theta are positive and remaining are all negative. So here, if you see here, cos 180 minus theta is again cos theta. So here cos theta is nothing but cos pi by 4. So in this 180 minus theta, only sine and cosecant are positive, remaining are negative. So here cos is negative and for sine this is positive. This will be minus sine pi by 4. Clear? So this is negative and this is positive. So here this will be minus 1 by root 2 plus I by, so this is again 1 by root 2. So we got the z value as minus 1 plus I times of this is root 2. So this is the second value. And next one, what is the third pole here? So z value is equal to, first one is cos pi by 4, cos 3 pi by 4 and cos 5 pi by 4. So this value is cos 5 pi by 4. This value is cos 5 pi by 4 plus this is I sine 5 pi by 4. And if you watch this one, so this can be written as z is equal to cos of, so this is pi plus pi by 4. So if you balance this one, if you take 4 as LCM, this will be 4 pi plus pi. And this is I sine of, this can be written as pi plus, this is pi by 4. And see here, this is 180 plus theta. So if you go with 180 plus theta, so here is 180 plus theta. Here only tan and cot are positive, remaining are all negative. So here we got the negative values as this is minus cos pi by 4. This is minus I sine of, this is pi by 4. So pi by 4 value I said you, this is 1 by root 2. This is minus 1 by root 2 minus I times of, this is 1 by root 2. So our z value is nothing but minus 1 minus I by root 2. And the next one here is z value. The next pole value here is z is equal to, this is cos 7 pi by 4 plus this is I sine of, this is 7 pi by 4. This 7 pi by 4 can be written as, 7 can be written as, see here, this is z is equal to cos of, this is 2 pi minus pi by 4. See here, if you take 4 as LCM, this will be 8 pi minus 1, again 7 pi. This is minus I sine of, this is 2 pi minus pi by 4. 2 pi is nothing but 360 degrees minus theta. So if you go with 360 minus theta, here cos theta is positive. Cos theta is positive and secant is positive. Remaining are all 0. So here the cos value is positive. So z is equal to, this is cos theta, cos pi by 4 and remaining are all negative. That is minus I sine pi by 4. So our z value will be 1 by root 2 minus I by, this is root 2. So we got the z value is 1 minus I by root 2. So we got all the poles ready here. First one with cos pi by 4 plus I sine pi by 4, we got the z value as, see here, this is 1 plus I by root 2. And with cos 3 pi by 4 plus I sine 3 by 4, after calculation, we got our z value as minus 1 plus I by root 2. So for cos pi by 5 pi by 4 plus I sin pi by 4, we got the z value as minus 1 minus I by root 2. And see here, for z value cos 7 pi by 4 plus I sin 7 pi by 4, we got our z value as 1 minus I by root 2. So our four pole values here are z is equal to 1 plus I by root 2, and next one minus 1 plus I by root 2, z is equal to minus 1 minus I by root 2, and z is equal to 1 minus I by root 2. So these are all the poles. And how we have to find the residues? So in order to find the residues, see here, now let the function f of z is given as, from the question, this is z square by, this is z power 4 plus 1. And now let us take f of z value as two functions. First one is, this is phi of z, and next one is, this is xi of z, xi of z. And in order to get the residues, see here, the residue value will be the residue of f of z at point z is equal to z naught value is equal to, the first thing here is phi of z naught by, see here, psi dash of z naught. We have to make a derivative for this. So what is phi of z naught? What is phi of z first of all? Phi of z is nothing but, see here, phi of z is the numerator. See, phi of z value is equal to the numerator z square, and xi of z value is nothing but z power 4 plus 1. So first I'm writing this one as a z square and making a derivative here. So for z power 4, this will be 4 into z cube, and we have to put z is equal to z naught here. So if I cancel for 2 times, what remains here? 4 by z at point z is equal to, see here, z naught, and therefore residue, our residue of f of z at point z is equal to, see here, z is equal to, see here, it's not 0, it is z naught. At point z naught is equal to, we have to substitute here as 4, 1 by 4 into z naught. Clearly we have four pole values here. The first pole value here is z is equal to, see here, z is equal to 1 plus I by root 2. Clear? See, the first pole value is 1 plus I by root 2. And see, our residue value of z is equal to residue of f of z at z is equal to, this is 1 plus I by root 2 value will be, that is 1 by 4 times of z naught. So here our z naught value is 1 plus I by, this is root 2. Clear? So if I send root 2 to the numerator, and 4 can be written as 2 into 2. So 2 again can be written as root 2 into root 2 by into 1 plus I. If I rationalize this one, if I multiply with 1 minus I in the numerator and denominator and cancel this one, this will be 1 minus I by, this is 2 root 2, and this is a plus b into a minus b is nothing but a square plus b square. So the value here is 1 minus I by, this is 2 2s of 4, this will be 4 root 2. So this is our residue value of f of z at z is equal to 1 plus I by, this is root 2. This is our first residue value. And the next one, for the second pole also we have to do the same. For the second pole here, what is our second pole value here? The second pole value here is z is equal to, see here, residue of f of z at the second pole value, that is minus 1 plus I by root 2. Now we have to substitute in which function? This one, 1 by z naught. So 1 by 4, see here, 1 by 4z at point z is equal to, this is minus 1 plus I by root 2. So this is root 2. If I substitute here, then this will be, see here, this value will be 1 by, this is 4 into minus 1 plus I by, this is root 2. If I send root 2 to the numerator, and 4 can be written as 2 into 2. So 2 again can be written as root 2 into root 2, and this is minus 1 plus I. So if I rationalize this one, minus 1 minus I, minus 1 minus I, if I multiply and see what happens, if I cancel this root 2, and this will be minus 1 minus I by, this is 2 root 2, and this is a plus b into a minus b. So this will be a square minus this value is b square. So this will be 1 plus 1, again this is 2. This is minus 1 minus I by this is 2 root 2 into this value is again 1 I square minus of minus plus 1. So this value is minus 1 minus I by 2 2s are 4. So 2 2s are 4, this will be 4 root 2. So this is nothing but residue of f of z at point z is equal to minus 1 plus I by root 2. Clear? So hope you all guys understand this one. So this is so simple if you follow this video. And the next pole value here is, the next pole value here is, the third one is minus 1 minus I by root 2. See here, minus 1 minus I by root 2. So again, the residue of f of z. So the residue of f of z at point z is equal to minus 1 minus I by root 2. Here is nothing but 1 by 4z at point z is equal to minus 1 minus I by this is root 2. So if I substitute the same thing here, so this will be 1 by 4 into this is minus 1 minus I by this is root 2. If I send root 2 to the numerator, and 4 can be written as 2 into this is root 2 into root 2, this is minus 1 minus I. So if I multiply with minus 1 plus I in the numerator as well as denominator, and see this value, if I cancel this root 2 in the numerator, this will be minus I plus 1 minus 1 plus I into, so this is 2 root 2, and this is again minus 1 whole square minus this is I square. So this value is I square, and therefore we got the value as, this is the value, that is minus 1 plus I. See here. So this can be written as minus 1 plus I by this is 2 root 2, and this is minus 1 square is 1 and I square minus 1 minus of minus plus 1. So we got the value as minus 1 plus I by this is 4 root 2. So this value is nothing but residue of f of z at point, see here which point it is, the third point. The third point here is minus 1 minus I. So z is equal to minus 1 minus I by root 2. So the value here is minus 1 plus I by 4 root 2. So this is our fourth value. So this is our fourth value. And the next thing here is the last one here. The pole value here is 1 minus I by root 2. So here residue of f of z at point z is equal to 1 minus I by root 2 is nothing but 1 by 4z at point z is equal to 1 minus I by root 2. So if I substitute the same thing here, so this will be 1 by 4 into this is 1 minus I by this is root 2. If I send root 2 to the numerator, and see 4 can be written as 2 into 2 can be written as root 2 into root 2. This is 1 minus I. So if I rationalize this one, this will be 1 plus I, and again this will be 1 plus I. So if I cancel 1 root 2, and this will be 1 plus I by this is 2 root 2. A plus b into a minus b is nothing but a square minus this is b square. So this is 1 plus I by 2 root 2 into this is 1 plus 1. This will be 1 plus I by this is 4 root 2. So which value it is? This is residue of f of z at point z is equal to 1 minus I by root 2. So this is our fourth residue value. So we got all the residue values here. So we found the poles and the corresponding residues. So for this pole, 1 plus I by root 2, see here, 1 plus I by root 2. So this is our residue value, first residue value. And for the next one here is minus 1 plus I by root 2. For this pole, after substituting minus 1 plus I by root 2. So this is our residue value. And for the third pole, so this is minus 1 minus I by root 2. So for minus 1 minus I by root 2, minus 1 minus I by root 2, and let's show you. So this is our residue value, and for the last one, that is 1 minus I by root 2. That is 1 minus I by root 2. So 1 minus I by root 2, this is our residue value. So I have shown all the 4 residues here and the corresponding poles here. So this is how we have to solve, and let me tell you once again about this. So this is the most important question. See once again, so it was asked to find out the residues of the function at those poles which lie inside mod z is equal to 2. So this is the function. In order to get the poles, we have to equate the denominator to 0. So after equating denominator to 0, so we can write minus 1 as cos pi plus I sin pi. So in general, I am writing cos 2n pi plus pi by 4 plus I sin 2n pi plus pi by 4. So here n values are 0, 1, 2 and 3. So if you keep n is equal to 0, so this is the pole, and if you keep n is equal to 1, this is the pole. If you keep n is equal to 2, this one, and n is equal to 3, this one. So these are all the 4 poles which are obtained when we equate the denominator to 0, and usually cos pi by 4, cos 45 degrees value is 1 by root 2 and sin pi by 4 value is 1 by root 2. Clear? So we have to calculate all these values. So in order to calculate all these values, this is also so simple. Cos pi by 4 is very clear as 1 by root 2, and sin pi by 4 is also very clear as 1 by root 2. So this can be written as 1 plus I by root 2. And cos 3 pi by 4 plus I sin 3 by 4 can be written as pi minus pi by 4 cos pi minus pi by 4. See here, for cos 180 minus theta is minus cos theta, and for sin 180 minus theta is plus sin theta. So this is minus 1 plus I by root 2. And for cos pi 5 pi by 4 and I sin pi 5 pi by 4. So 5 pi by 4 can be written as pi plus pi by 4. So this is also pi plus pi by 4. So this is cos 180 plus theta is nothing but minus cos theta, and next one sin 180 plus theta is nothing but minus sin pi by 4. So this can be written as minus 1 minus I by root 2. So here again for cos 7 pi by 4 can be written as 2 pi minus pi by 4, and this is also 360 minus pi by 4. So this is 1 by root 2 minus I by root 2. So this is z is equal to 1 minus I. So this is 1 minus I by root 2. So these are all the pole values which are obtained after equating the denominator to 0. So all the values are within the circle mod z is equal to 2. Clearly these are all the 4 poles. This one is the first one, second one, third one and fourth one. So in general, we have to take f of z is equal to z square by z power 4 plus 1. So we have to take the numerator as one function and denominator as another function. So if it is in this form, so p by q form, so we have to write it for getting the residues, we have to write as phi of z naught by phi dash of z naught. So phi of z naught. So what is phi of z? Phi of z is nothing but z square, the numerator. And for the denominator, we have to make a derivative, that is 4z cube. After cancelling, so this will be 1 by 4z at z is equal to z naught. We'll get the residues. So first residue is 1 plus I by root 2, and after substituting here, we got this residue value as 1 plus I by 4 root 2. And the second residue value here is this one minus I plus 1 by root 2, and after substituting here we got the residue value as this one. And next one, the third one is minus 1 minus I by root 2. After substituting here and calculating, we got the residue value as this one. And next, the fourth one, 1 minus I by root 2. After substituting here and calculating, we got the residue value as 1 plus I by 4 root 2. So this is how we have to solve. This is the most important question. So repeatedly asked a question. So hope if you really like and if you really understand this one, please practice and score more and pass it on to your friends. And thank you for staying till the end.